Who's in the lead? Who's catching up?
Deepseek R1 is all about reasoning. It's almost like a master strategist, mirrors how human programmers would learn, uses a technique called chain of thought reasoning.
NanpengTV Podcast, Episode 1.
Welcome to NanpengTV Podcast. In today's episode, we are discussing two of the most powerful Chinese large language models, Deepseek R1 and Qwen 2.5 Max. This episode of the podcast is perfect for non-developers who wants to learn AI concepts like reasoning-focused development, reinforcement learning and reinforcement learning from human feedback, supervised fine-tuning, proximal policy optimization algorithm, rule-based reward system, distillation techniques, evaluation metrics, mixture of experts architecture, LLM's multimodal capabilities. Without a further ado, let's get into it.
All right, everyone, get ready. We're diving deep into the world of Chinese large language models today. You guys sent us a ton of articles and research papers, and it's an interesting mix, to say the least. So we're here to go through it all. We're talking about models like Qwen 2.5 Coder and Deepseek R1, which are going head-to-head with the big names like OpenAI's GPT-4, and then we'll also be looking into the open source side of things. There are tons of Chinese LLMs out there, and it's really a fast-paced environment. So by the end of this deep dive, you'll know a lot about these models, but you'll also get a sense of the bigger picture, like who's in the lead, who's catching up, and what this all means for the future of technology. So let's jump right in. Let's start with Qwen 2.5 Coder. What can you tell us about this one?
Yeah, Qwen 2.5 Coder. This one's developed by Alibaba, and it's made specifically for coding. One of the most interesting things about it is how it's built, its architecture. It uses the transformer model, which is behind a lot of the really successful LLMs we see today. And get this, it was trained on a massive data set of 5.5 trillion tokens.
5.5 trillion. Wow, that's hard to even imagine. What are the challenges of training a model with that much data?
That's a great question. Training at that scale, you need a crazy amount of computing power and some very sophisticated engineering. You're essentially teaching this model to recognize patterns across a huge amount of text. But the results are incredible. With that amount of data, Qwen 2.5 Coder is awesome at code generation, code completion, even code reasoning. It can understand really complex coding ideas and create great code in multiple programming languages. It's not just putting out lines of code, it's actually understanding the logic.
It sounds like it's thinking like a programmer, which is both impressive and a little scary. The articles mentioned that they used a 3-stage training approach for this one. File level, repo level, and then instruction tuning. Can you explain what that means? What's the benefit of that?
It's pretty fascinating, actually. It sort of mirrors how human programmers would learn. In the first stage, they trained the model on individual code files, so it learns the basic syntax and how the code is structured. Then they moved up to the repo level, where it learns how the different files in a project all work together, kind of like learning how the pieces of a puzzle fit to make the whole picture, a whole program. And finally, they use what's called instruction tuning to teach the model how to follow instructions, complete coding tasks, like giving it a coding assignment and guiding it to the solution.
So it's like building up a deeper and deeper understanding of code, to the individual lines, all the way to the architecture of a whole project. That's super impressive. Speaking of impressive, let's move on to Deepseek R1.
Sounds good. Deepseek R1 is all about reasoning. It tackles complex problems by breaking them down into smaller, more manageable steps, It was developed by the Chinese company Deepseek. It's almost like a master strategist planning its moves to reach a solution.
Yeah. I remember reading that Deepseek R1 is really challenging the established models like GPT-4. It's even outperforming them on some benchmarks, which is amazing.
It really is. Deepseek R1 uses a technique called chain of thought reasoning, which essentially means it's thinking step by step, just like a person would, to solve a complex problem. It breaks down the task into these logical steps, and it even generates reasoning steps before getting to the final answer.
So it's not just giving an answer, it's showing its work, kind of like we had to in a math class, showing each step of the equation.
Exactly. That's a great way to put it. And this approach has made Deepseek R1 amazing in areas like math, coding, and just general knowledge. It's getting really high scores on tough math benchmarks like AIME 2024 and Math 500.
And holding its own in coding benchmarks like Codeforces, which is like competing against really skilled human programmers. That's incredible.
It is. And what's even more interesting about how they trained Deepseek R1 is they used pure reinforcement learning, no supervised data at all. So the model learned just through trial and error, guided by a reward system.
Like teaching a dog a new trick, rewarding good behavior. But instead of treats, it's getting feedback on how well it performs. And something that stood out to me in the research was that they used a rule-based system to give rewards to the model instead of using another neural network. Can you tell us more about why they did that?
That's a really good observation. It shows how much they're focused on transparency and control. So instead of using a complex neural network for the rewards, which can be a bit of a black box, they made a rule-based system. So the reward is decided based on these predefined rules. For example, if you give the model a coding task, it gets a reward if the code actually works and gives the right output. In a math problem, the reward depends on if the answer is right.
So a very straightforward and clear approach to feedback. But is there a downside to that? Could these rules actually limit how much the model can learn in more nuanced ways?
That's a very insightful question, and it brings up a core debate in reinforcement learning. The balance between having clear rules and having flexibility. So on one hand, these rule-based systems give really clear and objective feedback. They're less likely to be biased, which can happen with human-generated rewards. But it can be difficult to make rules that cover every possible situation in a complex task. It's like trying to write a rule book for every possible move in chess, right? You can cover the basics, but there will always be situations that need intuition and creativity, and that's where the flexibility of a neural network-based reward system might be better.
So it's an interesting trade-off. Deepseek chose clarity and control with rules, but it does make you wonder if that might limit what the model can do in the future.
Exactly, and it's a question that's being actively researched as they try to push the limits of reinforcement learning.
Now, Deepseek also took their very sophisticated R1 model, and they used something called distillation to create smaller, more accessible versions, right? Can you explain how that works?
Yeah, absolutely. Model distillation is becoming very popular in the LLM world. Imagine you could take everything a grandmaster chess player knows and somehow transfer that knowledge to someone who's just starting out. That's essentially what model distillation is trying to do. They train a smaller model to mimic the big, complex Deepseek R1 model. So the smaller model learns from the teacher model and gets its knowledge and reasoning abilities in a much smaller package.
So they're not copying the structure of the model, but they are copying how it makes decisions. And I see they've done this with different sizes of Qwen and Llama models, so now there's a whole family of these distilled Deepseek R1 models.
Exactly. They've experimented with different base models and sizes to find the sweet spot between performance and efficiency. And the results are really cool. Some of these smaller models are doing amazingly well on tasks like Math 500, which tests high school level math problems.
And that's a huge deal for making these models more accessible. Now, you don't need a supercomputer to use them, right? Developers and researchers with less resources can try out and build on these smaller Deepseek R1 versions.
Exactly. It's making this advanced reasoning technology available to more people. And Deepseek has made these models available on their web-based chat platform and through their API, too. This opens up tons of potential applications, from simple things like answering questions to being integrated into more complex software.
So we've got this powerful reasoning model, Deepseek R1, and they've made it more accessible with distillation, which gives developers more options. That's a smart move. But it's not just about these two models, right? There's a whole ecosystem of open source Chinese LLMs out there, isn't there?
Absolutely. That's what we'll explore next. Beyond these two big names, there's this whole vibrant open source scene that's really pushing the limits of LLMs. Stay tuned as we delve into that exciting landscape.
Yeah, it's like a whole garden of AI blossoming over there. You've got models like ChatGLM, which is known for being really good at conversations, and by Swan, which is doing really well on these Chinese benchmarks. And it's amazing how diverse this open source scene is. It's not just these general purpose models. There's some very specialized models popping up, focused on very specific tasks and domains.
That's right. For example, we've got Bianque, which is designed specifically for medical conversations. It understands medical terms, and it can even talk about health and wellness. And then there's Lawyer Llama, which has been trained on legal texts, so it can help with things like research and analyzing legal documents.
It's almost like having instant access to a team of experts, all powered by AI. A doctor, a lawyer, a programmer. It's incredible.
It is, and the possibilities are huge.
Yeah.
This open source approach really makes this powerful AI technology accessible to everyone. Researchers can work together, developers can build new applications, and ultimately it just speeds up how fast innovation happens.
And it brings up some interesting questions about jobs in the future. I mean, if these AI models can handle tasks in fields like medicine and law, what does that mean for the people who work in those fields?
That's a really important question. But it's not about replacing human experts. It's more about giving them new tools. Imagine doctors using Bianche to quickly analyze a patient's symptoms and suggest possible diagnoses. Or lawyers using Lawyer Llama to go through tons of legal documents and find important precedents.
It's like having this super intelligent assistant who can handle all the routine stuff, which frees up the humans to focus on the more complicated and nuanced parts of their work.
Exactly. And the open source approach means people can customize and adapt these models. Developers can take the basic models and fine-tune them for their own specific tasks. It's leading to even more specialized AI tools.
Kind of like taking a recipe and then adding your own spices to make a dish exactly how you like it.
Yeah, that's a great analogy. And it's this kind of flexibility that's driving a wave of new ideas and innovation in the Chinese AI world. And it's not just about the models themselves. There are tons of open source tools and frameworks popping up to help people develop and use these models.
That's right. We've got tools like Flaggyfall, which provide standardized benchmarks to see how well different LLMs are performing. It's like having a standard way to measure how capable different models are.
And then there are training frameworks like DeepSpeed Chat that make it easier to train these huge language models on massive data sets.
And don't forget about deployment frameworks like VLLM, which are designed to run these large models efficiently on different types of hardware. So like this whole ecosystem is coming together and pushing progress in the field forward.
You got it. And it's this collaborative, open source spirit that's really pushing Chinese LLMs forward.
But it's not just about copying what's already been done, right? Chinese researchers and companies are also pushing the boundaries and trying out new things with LLMs.
That's right. One area where we're seeing a lot of innovation is long context understanding.
Oh yeah, remind me, what exactly is that again?
It's the model's ability to process and understand really long pieces of text, like maybe even a whole book or a long research paper. And this is super important for things where the model needs to remember information from earlier parts of a conversation or a document.
So like having a super memory that can remember everything from a conversation or text, no matter how long it is. Why is this such a big focus for Chinese LLM development?
Well, it's partly because of how the Chinese language works. Written Chinese often uses these really long and complex sentences with connections between different parts. So being able to understand these long sequences of text is really important for accuracy in language tasks. And some of these Chinese models are being trained on absolutely massive amounts of data, way more than a lot of Western models, which means they can handle much longer contexts.
So they're pushing the limits of what LLMs can do, not just how big they are, but also how well they can understand and process complex information, like training for a marathon instead of a sprint.
Exactly. And another area that's really exciting is multimodal learning.
Now that's something I'm curious about. Multimodal learning seems to be getting a lot of attention in AI in general. What makes the Chinese approach to multimodal LLMs different?
One thing is that they're really focused on combining understanding the Chinese language with visual processing. So there are models like Visual GLM 6B that are trained on huge data sets of Chinese text and images. They're learning to understand the connections between the two.
So it's not just translating between languages, but translating between different types of data, images, text, maybe even audio at some point.
Yes, exactly. And that opens up some amazing possibilities for things like image captioning, where the model describes what's happening in a picture, or visual question answering, where it answers your questions about an image. We could even see AI systems that interact with the world much more like a human would.
I'm starting to see a pattern here. They're using tons of data, pushing the limits of model size and performance, and they're going after these really tough tasks like reasoning and multimodal understanding. It's clear that China wants to be a major player in the AI world.
Yeah, it seems like they're playing a whole different game and they're winning. So what does all this mean for AI around the world? How is the rise of these Chinese LLMs going to change things?
That's the big question, isn't it? Things are definitely shifting, and it's hard to say exactly what will happen. Some people think all this competition will just make innovation go faster, and we'll see even bigger advances in AI.
Like a tech arms race, but with AI instead of weapons.
Yeah, exactly. And this competition could lead to both sides investing a lot more in research and development, which could result in breakthroughs that benefit everyone. But there are also worries about something called an AI divide.
An AI divide. What's that, and why is it a concern? Well, it's the idea that different countries or regions might end up developing their own separate AI ecosystems. Imagine Chinese LLMs dominating some areas, while Western models are better in others. It could lead to things becoming fragmented, where the data, the tools, and the experts are all separated. That can make it harder for people to collaborate and could actually slow down progress.
Like building separate towers of Babel, each one speaking a different AI language. That doesn't sound good at all.
Exactly. And this divide could go beyond just technology. It could affect things like trade, research, and even how countries interact with each other.
So it's not just about who has the best AI. It's about how these technologies are created, shared, and used in the world.
Exactly. And we need to start talking about this now while these technologies are still developing. We can't just focus on the tech advancements we have to think about the ethics and the global implications, too.
Speaking of ethics, we were talking before about Deepseek using those rules for their reward model in reinforcement learning. Let's go back to that for a minute. You mentioned that there's this balance between being clear and being flexible. Can you explain that a bit more?
Sure. So remember, the reward model is there to tell the main model whether its answers are good or bad. Deepseek went with a rule-based approach, meaning they set up specific rules to determine the reward. Like if the model generates code that works, it gets a positive reward.
So it's very transparent. What's the other way to do it, and why would someone choose that?
Well, the alternative is to use another neural network as the reward model. And this reward model is trained on lots of examples, so it learns to figure out what humans prefer. It's kind of like having a separate AI that acts as a judge for the main model.
So instead of having rules, you're training this reward model to learn what a good response looks like based on what humans say. It sounds like it could be more flexible, but also a lot more complicated.
That's right. A neural network-based approach can handle more subtle differences and adapt to situations that the rules might not cover. But it also adds complexity and the possibility of bias, because how well the reward model judges things depends on the data it was trained on.
So there's a trade-off. Do you go for transparency with rules or adaptability with a neural network? Deepseek decided to prioritize transparency, but it does raise the question of whether that might limit how much their model can learn over time.
You got it. And this is a big challenge in reinforcement learning, finding the right balance between being clear, being flexible, and being effective with this reward model. It's something researchers are working on because the choices they make can really impact what the AI can do and how it behaves.
So as we wrap up our deep dive into these Chinese LLMs, I'm feeling kind of amazed, but also a little unsure. The progress is incredible. It's pushing the boundaries of what we thought AI could do. But it also makes you think about the future. How is this technology going to change our world, and how do we make sure it's developed and used responsibly?
That's a really important point. We're just at the beginning of this journey. We've talked about some of the key players and trends, but the field is constantly changing. I think the most important thing is to stay informed, be part of the conversation, and keep a critical eye on things as these technologies shape our world.
I agree. We've covered a lot today, from the technical details of these models to the bigger picture of what their rise means. It's clear that Chinese LLMs are a major force in AI, and they're already having a big impact on the global landscape. Keep learning about this exciting field. You never know what you might find.